Jonathan Amory.
I'm Christine Goulet. Something to do with entomology. What do you have?
Robots. So for the past 5 years, I was an advanced robotics engineer for a company called Boston Dynamics. I helped design and build some of the most sophisticated robots on Earth. However, about 5 months ago, I gave that up to come back to Maine and teach engineering in the middle school.
Oh, bless you. What school?
Freeport.
Cool.
Okay. So I'll talk about these guys in a second, but I want to talk a little bit about what led me to here. Before going to college, I studied boat design at the landing school down at Kennebunkport. And in hindsight, this was probably the most important decision I made because it's really the first time I got to experience real engineering and engineering approach and principles. And engineering is different than most other fields because, including science, because at its core, it's really deductive. You're applying broad principles of math and science to solve specific problems. And science, on the other hand, is very inductive. You're studying many small phenomena, you're cultivating them to form a broader principle. And I think this distinction leads to one of the biggest fallacies is that people assume that if you're a good scientist, you make a good engineer and vice versa. And I credit a lot of my success later on, both academically and professionally, with getting this head start in engineering. So I went to school to study mechanical engineering, but I didn't completely neglect my naval architecture. This here is Skimmercat. It's a planing catamaran with articulating hulls. It was built on a shoestring budget. It was my senior project, and it's able to sail about 40% faster than the wind. It's also won the American Society of Mechanical Engineers National Old Guard competition. After graduate school, after college, I went to graduate school, and I went on to study digital media at Harvard Design School. And I wanted to broaden my horizon and fill in gaps in my kind of design philosophy. And the design school caters more towards architects who view design from an aesthetic point of view as opposed to engineers who are looking purely at functionality. So here's some of the renderings I did. I also got to use you can see my mouse here. I also got to use a lot of CAD programs, which was one of my strengths. This here is a short animation that I did using Maya, which is the same software that Pixar uses to make their movies. And I also got to work with interactive spaces. I'm kind of running through this because there's not much time. This here is an interactive wall. It uses a small webcam, and it can do blob tracking. This blob tracking algorithm, and the wall will actually interact with the person as they go move in front of it and stuff like that. So that was kind of some of the fun stuff I got to do in graduate school.
I would love to write your contact info down.
Okay.
So you seem like you would have some great ideas for students.
Yeah. So this here is it starts up. This here is Big Dog. Well, I went on to Boston Dynamics and did robotics. I never actually touched a robot before joining the company, but they saw that I had strong design skills and engineering background. So they took me anyways, and over my course of working there, I was there for about 5 years. I worked on about 7 or 8 different platforms, and I designed many of the mechanical systems and subsystems on these various platforms. Big Dog is probably the most famous robot that we have. It's the most popular video on YouTube as far as science and technology goes, and what it's able to stand out is that it's able to cover a large range of terrains, and it can handle large perturbations. Most of the robots out there are wheel to track. Very easy to design, very easily to build, but they can't really handle things like this. So we wanted to build robots.
Like a cult.
Yeah, we wanted to build robots. If we had more time, I'd show you a video of this thing slipping on ice. It's amazing. It can withstand almost anything. So, we wanted to build robots that can handle real-world situations. We also...
So did the military pay for that?
Yes, it's DARPA funded, so it's an offshoot of the military. This here is also another DARPA robot. It's part of a learning locomotion program. We gave these out to a bunch of universities, and they use it to go over different terrain, and these robots can actually learn on their own. Another robot I worked on was the wall climbing robot. This is a robot that's based on geckos and cockroaches. And if you ever saw Spider-Man, you know how he grows the little hairs out of his hands? It actually climbs in a very similar way. If you look down at the feet there, you'll see that it's got many, many little individual hooks that cling to the asperities on the wall, and each hook has its own compliance that it's able to adapt to the surface. By distributing its weight over these tiny little hooks, it's able to support its mass. So it can climb on anything about the roughness of 60 grit sandpaper.
Now, do you have to design the chips to make these work too? Or?
We don't design the chips. We design we take the chips, and so the electrical engineers build the computers that they use to run. I was a mechanical engineer, so I designed the actuators, the frame, things along those lines. So, as I mentioned, I felt that a lot of my success came from having a chance to see engineering before going to college. So I wanted to give that opportunity to other people. I'd always kind of taught a little bit since I was the age of 13 and loved it. So I moved back to Maine and tried to do what I could. I've been teaching for 5 months. My classes are all driven by the students. So what the students want to do is what we try to do. So I got some students that wanted to build a 12-foot sailboat. So we're building a 12-foot sailboat using composites and some wood and things along those lines. Other students wanted to build a hovercraft. So we had them build a hovercraft using a small leaf blower engine. This thing can hold 6 students. We could probably hold more. I just couldn't put any more students on the thing. Another student was interested in the animation in Maya, and so this is this little Maya animation he did. He learned Maya in 5 weeks. He did better than the graduate students that I taught. I have other students that were interested in origami. Origami right now is the forefront of mathematics. They're doing protein folding to solve cancer using origami principles, as well as telescopes, airbags. A lot of science is going in, and mathematics
So
is going into origami.
those are the models that they're using to understand the product?
Exactly, or to actually shape the proteins. They're building proteins based on how they fold based on origami principles. And so I would mention this, and these girls were very excited by that. And they took what they had learned from the origami and folding paper they wanted to make a sculpture out of it. So they took a piece of plywood and made it so that it would fold up like a piece of paper would. So you can see this plywood there, and it folds up into a falcon. And as far as we can tell, they're the only people who have ever done something like this. I have other students that were more into carpentry, so they built a bench that's based off a CAD model, and it's designed so you can't see any of the fasteners. So all the fasteners are hidden on the bench. And then we have other programs such as Lego robots. We have a group of students that are building a folding rowboat, and some students that are doing tent design. So they build little scale models of tents.
Now, these classes, what is the classification of the class?
It's technically a technology class.
Okay.
Kind of the former shop. But I'm having the students learn some engineering, so I taught them statics this year. So they learned about forces and moments. I taught them a little bit about deflection, materials, material properties, things along failures. So I'm trying to weave in more engineering things. So we'll do a group project or a class project for about a month. We'll do a little bit of a lesson on statics or some engineering principle. We'll do some electricity and magnetism this spring with the 7th graders, and maybe some power system stuff. And then we'll go on to have them do a group project of their choosing where they get to do any one of these larger projects.
So how long is your class? These students here, do they see you daily for like 50 minutes?
They see me 3 times a week for 75 minutes per class.
I bet you they love it.
So far
Very neat. Very neat.
And do they stay with you from year to year, or can they?
Unfortunately, this is my first. I've only been doing 5 months.
Right, but the plan, is there a plan to have them?
Budget cuts. I have no idea what's going to happen. I mean, I might not have a job.
What grade are you?
This is 7th and 8th grade. This is 8th grade.
8th grade.
Yeah.
7th and 8th, or 8th?
Well, this year is 8th. I had 8th for the first semester. I'm going to have 7th for the second semester.
Got it. Okay.
So if I had my way, I would like to have 8th for the whole year. I think I could do a lot more with them, but this was the school that I was moving into, so I'm doing
Well,
what
and
this
it's probably to give kids a taste of what it's like, and as many kids as possible get that taste. Yeah. Very good. Yeah.
Well, so do you find that you can get all the kids engaged?
Yes and no. I mean, there's always some kids that are. I found that I've actually been able to get most of the kids engaged, and a lot of it's because they get to choose the programs that they wanted to.
That's right.
I think I don't want to have them just do one thing or something that I'm interested in. I want them to see technology as something they're interested in. And so in that case, I'm getting more kids involved. The other thing I do is that, when we have these group projects, it's student driven. So there's some students that sit on the side, and what they find after about a week of sitting on the side is it's really boring, and they're watching their friends do stuff that they think is really cool.
Yeah.
And so, every chance to get to them to re-engage, we can. And the students have been working in groups, and if you've ever worked in groups, you know how difficult it can be and how you have that 80-20 rule. The students actually did very, very well. I'd say it was, much better than any 80-20 I've ever seen, much better than any group I worked in college. So it was really good to see how the students work in groups. So.
Would you be open to having me come shadow? I'm the technology integration teacher in Monmouth, but I don't teach students, I teach teachers.
Okay.
And I